You walk into a grocery store on a Tuesday morning. Nothing unusual. You grab a cart, head for the produce section, and then you stop. Half the shelves are empty. Not restocking day empty. Stripped. The apples are gone. The avocados, gone. Blueberries, cherries, watermelon, cucumbers, almonds, broccoli, squash. All of it. Vanished. You check your phone to see if you missed some kind of emergency. You didn't. What you missed is much smaller than that. About 5 grams smaller. Because somewhere, roughly 12 hours ago, every bee on Earth disappeared. Now, your first reaction might be the same one most people have. Okay, no more honey. That's annoying. I liked honey in my tea. And sure, that's technically true. No more honey. But honey is a rounding error in what's about to happen. Because bees don't just make honey. They hold together a web of systems so vast, so interconnected, that pulling them out doesn't just create a gap. It starts a clock. And the things that clock is counting down are going to surprise you, because almost none of them seem like they have anything to do with bees. A single honeybee visits somewhere between 1,000 and 5,000 flowers every single day. She makes 10 to 15 trips from the hive, hitting 50 to 100 flowers each run, carrying pollen from one plant to the next. Multiply that by the roughly 2 trillion bees estimated to be alive at any given time, and you begin to see the scale of the engine that just switched off. This isn't a nice to have. This is infrastructure. Invisible, flying, fuzzy infrastructure that underpins a significant fraction of everything you eat, wear, and feed to the animals that become your food. And it just vanished. So let's start the clock. Within the first 24 hours, most people don't notice. Bees are quiet workers. Nobody's checking on hive populations over breakfast. The first people to know are the commercial beekeepers, and they know because the silence is deafening. A healthy hive hums. You can hear it from several feet away, this low, constant vibration. Imagine stepping out to check your hives and hearing nothing. 60,000 bees per hive, just gone. No bodies, no swarm, no trail. Every single managed colony on the planet, empty. Beekeepers start calling each other. Then they start calling everyone. Within hours, agricultural extension offices across the American Midwest are fielding calls that all sound the same. They're gone. All of them. And the timing could not be worse, because we're about to talk about almonds. California grows 80% of the world's almonds. That's not a typo. One state, one crop, 80% of global supply. And almonds are 100% dependent on bee pollination. The trees cannot produce nuts without bees. Every February, something remarkable happens. Roughly 70% of all commercial honeybee colonies in the United States get loaded onto flatbed trucks and driven to California's Central Valley. Around 1.7 million hives converge on the almond orchards for what scientists call the largest managed pollination event on Earth. Growers pay over $200 per colony for the privilege of renting those bees. In 2025, the total pollination bill for California almonds alone topped $360 million. Those trucks aren't coming this year. The hives are empty, and almond trees are already in bloom, their white flowers opening to nothing. No buzz, no movement, no pollen transfer. Those flowers will wither and drop. No almonds will form. And because California almonds are a $5 billion industry, the financial shockwave starts immediately. Almond futures spike. Almond milk vanishes from shelves within weeks. Every product that uses almond flour, almond oil, almond extract starts scrambling for alternatives that don't exist at scale. But almonds are just the opening act. Within the first week, agricultural scientists start publishing emergency assessments, and the numbers are staggering. 75% of the world's flowering crop varieties depend on animal pollination, primarily bees. That doesn't mean 75% of all food disappears, because staple grains like wheat, rice, and corn are wind-pollinated. They'll survive, but here's what won't. Apples, pears, peaches, plums, cherries, raspberries, strawberries, blueberries, cranberries, mangoes, kiwi, passion fruit, lychee, cocoa, coffee, vanilla, tomatoes, peppers, eggplant, zucchini, squash, pumpkins, cucumbers, melons, onions, carrots grown for seed, broccoli and cauliflower grown for seed, sunflowers, canola, coconut. That list just reshaped the global diet. Coffee deserves its own moment here because 2.5 billion cups of coffee get consumed every single day worldwide. Coffee plants benefit significantly from bee pollination, with studies showing yield increases of 20 to 25% when bees are present. Without bees, coffee production drops hard. The price of a cup of coffee doesn't just go up. In some regions, coffee farming becomes economically unviable. Billions of people are about to have a very different morning. Now here's where the cascade starts to pick up speed, because there's a crop on that list you probably didn't think about: alfalfa. And alfalfa changes everything. Alfalfa is the third largest crop in the United States, after corn and soybeans. Most people have never thought about it because humans don't eat it directly. Cattle do. Dairy cows, beef cattle, horses, sheep, goats. Alfalfa is the protein backbone of American livestock feed, and it is almost entirely dependent on bee pollination for seed production. Not honeybees specifically. Alfalfa has its own specialist. The alfalfa leaf-cutting bee trips 80% of the flowers it visits, compared to honeybees, which manage about 10%. Both of them are gone now. Without pollinators, alfalfa seed production collapses. That means no new alfalfa crops. Existing fields can be harvested for one more season, maybe two if you stretch the perennial roots. After that, the feed supply starts drying up. And when cattle feed disappears, cattle disappear. Not overnight, but fast enough to restructure the entire meat and dairy industry. Beef prices spike, milk prices spike, cheese, butter, yogurt, ice cream, all of it becomes scarce because the animals that produce these things can't eat. Follow that thread one step further. Leather comes from cattle. Less cattle means less leather. Shoe companies, furniture makers, car interior manufacturers, fashion houses. They all just got a supply problem that traces back to a missing insect. Think about that chain for a second. Bees disappear. Alfalfa seeds don't form. Cattle lose their primary protein feed. Herds get culled. Leather supply drops. The price of a couch goes up. Because of bees. And we haven't even talked about cotton yet. Cotton is technically self-pollinating, but research shows that bee pollination increases cotton yields by 15 to 60%, depending on the region. In parts of West Africa, exclusion of pollinators causes yield drops of 37%. So the cotton supply doesn't vanish, but it shrinks, noticeably, at exactly the moment when everyone's scrambling for alternatives to leather and other animal-derived materials. The clothing industry just got hit from two directions at once. Around month 3, the full picture starts to emerge, and it's not just about what humans eat. It's about what everything eats. Wildflowers that depend on bee pollination stop producing seeds. Meadows that should be carpeting themselves in spring color start thinning out. These aren't just pretty landscapes, they're food sources. Berries that birds depend on. Seeds that rodents cache for winter. Fruits that bears and foxes and countless other species rely on to build fat reserves before cold weather. The collapse doesn't just move through agriculture. It moves through ecosystems. Birds that feed on bee-pollinated fruits and seeds start declining. Songbird populations drop because the insects that used to visit those flowers were also a food source for nestlings. Populations of animals that eat those birds start shifting. Predator-prey ratios change. And this is happening everywhere, on every continent except Antarctica, simultaneously. No ecosystem has time to adapt, because adaptation requires generations, and this happened in an afternoon. There's a quote often attributed to Einstein that says, "If bees disappeared, humans would have 4 years left." Einstein almost certainly never said that, but the misattribution stuck for a reason. People sense, even without the data, that removing bees pulls a thread that unravels something enormous. The data just proves them right. There's a place where we can see what this looks like, by the way. It already happened, on a smaller scale, in Hanyuan County in China's Sichuan province. In the 1980s, farmers there converted rice paddies to pear orchards because pears sold for 4 to 5 times the price of rice. To protect yields, they sprayed pesticides heavily, sometimes 12 applications before harvest. The local bees died off. The beekeepers moved their hives away, and the farmers were left with orchards full of trees that couldn't produce fruit. So they started pollinating by hand. Using bamboo sticks tipped with chicken feathers, they began dusting pollen from flower to flower. Couples would work 5 to 6 hours a day, the husband climbing into the upper branches while the wife handled the lower ones. 30 trees per day, every tree, every blossom, by hand. This is real. This isn't a thought experiment or a warning from a documentary. This is what happened when bees disappeared from one county in one province. Now multiply that by the entire planet. The math on hand pollination is brutal. A single bee colony can pollinate the equivalent of what would take dozens of human workers to accomplish. Scaling hand pollination to cover even a fraction of global agriculture would require a labor force that doesn't exist. In Sichuan, they managed it for pear orchards because the orchards were small and the pears were valuable. Try doing that for the almond orchards of California. 1.3 million bearing acres, every tree, every flower, with chicken feathers. By month 6, governments are in full crisis mode. The economic damage is measurable now. The global value of pollination services has been estimated at somewhere between $235 and $577 billion annually. That value is evaporating. Farm bankruptcies accelerate. Rural communities that depend on pollinator-reliant crops start hollowing out. Seasonal agricultural workers who pick fruits that no longer exist have no work. The supply chain disruptions ripple into food processing, packaging, transportation, retail. A Whole Foods store in Providence, Rhode Island once did an experiment where they pulled every product from their produce section that depended on pollinators. They removed 237 out of 453 products. 52% of their produce department. Gone. Now imagine that's not an experiment. Imagine that's every grocery store on Earth, and it's getting worse every month. Prices on remaining foods surge. Wind-pollinated grains, rice, wheat, and corn become the backbone of the global diet. Potatoes, which don't need pollinators, become strategic commodities. Countries that rely heavily on fruit and vegetable exports see their trade balances collapse. Spain exports billions of dollars worth of bee-pollinated produce annually. New Zealand's kiwi industry, Turkey's cherry orchards, Mexico's avocado farms, all hit. International trade disputes erupt over the remaining food stocks. Export bans go up. The politics of food scarcity have entered the chat. The world's food supply doesn't collapse entirely, but it contracts, hard. And it gets monotonous. Nutritional diversity plummets. Vitamin C becomes harder to get without citrus fruits and berries. Micronutrient deficiencies that had been declining for decades start climbing again, especially in developing nations where diet variety was already limited. Something else happens around this time that most people wouldn't predict. Medical research takes a hit. Bee venom contains a peptide called melittin, which makes up about half the dry weight of the venom. Melittin has been showing remarkable promise in cancer research. It's positively charged, and cancer cell membranes tend to carry more negative charge than healthy cells, which means melittin binds preferentially to tumors. Studies have shown it can suppress growth factor receptors in aggressive breast cancers, enhance the effectiveness of chemotherapy drugs, and kill glioblastoma cells in lab conditions. Researchers have been developing nanoparticle delivery systems to get melittin into tumors without the side effects of raw bee venom. All of that research just lost its source material. No bees means no venom. Existing stockpiles of melittin are finite. An entire branch of oncology research slows to a crawl at exactly the moment the world needs every medical breakthrough it can get. The psychological effects are harder to measure, but impossible to ignore. There's a term that environmental scientists use called shifting baseline syndrome. Each generation accepts the environment they grew up in as normal, so gradual degradation goes unnoticed. But this isn't gradual. This is all at once. Children born in the year the bees disappear will grow up in a world where strawberries are a luxury, where chocolate is rare and expensive because cocoa yields have cratered, where coffee costs what a good bottle of wine costs now, where the produce section of a grocery store is a fraction of what it used to be. They won't know what they're missing, but the generation that remembers will feel it every single day. Now, what about the other pollinators? Butterflies, moths, hoverflies, beetles, bats, hummingbirds. They're still here. Can they pick up the slack? The short answer is some, but nowhere near enough. Bees are the most efficient pollinators for the majority of crops because they've co-evolved with flowering plants for over 100 million years. Their fuzzy bodies are electrostatically charged, which makes pollen stick to them. They exhibit flower constancy, meaning they tend to visit the same species of flower on a given trip, which is exactly what you want for crop pollination. A butterfly might visit flowers, but it's sipping nectar through a straw without necessarily contacting the reproductive parts of the plant. Hoverflies help, beetles help, but none of them operate at the scale or efficiency of bees. Wild bee populations, bumblebees, mason bees, leafcutter bees, they're all gone too. Everything in the order Hymenoptera that we call a bee has vanished. Other pollinators will partially compensate. Some crops will struggle through at reduced yields, but the gap is enormous, and it's not closing. And here's something people forget. Colony collapse disorder has already been giving us a preview of this scenario for nearly 2 decades. Since the mid-2000s, beekeepers in the United States have been reporting annual colony losses around 30%. The managed honeybee population in America dropped from 6 million colonies in 1947 to under 2.5 million. Pesticides, parasites like the varroa mite, habitat loss, monoculture farming. The bees have been sending warning signals for years. This thought experiment just asks what happens if those signals become a flat line. Month 9. The 1-year mark is approaching, and the landscape itself has changed. Wildflower meadows are sparser. Orchards stand in rows of trees that bloomed and failed, bloomed and failed. Clover, which carpets pastures and fixes nitrogen in the soil, depends on bumblebees for pollination. Without new clover seeding, pasture quality degrades, which circles back to the livestock feed problem that alfalfa already started. The soil itself is affected because many of the plants that bees pollinate are the same plants whose root systems hold topsoil in place and maintain soil microbiology. Pull enough plants from an ecosystem and the ground starts to degrade. Farmers are adapting where they can. Greenhouses with mechanical pollination are being built at emergency speed. Some use tiny vibrating wands that mimic the frequency of a bee's buzz to shake pollen loose from tomato flowers. Others are experimenting with drones equipped with pollen-coated bristles. None of these solutions scale. A drone can pollinate a row of plants in a research greenhouse. It cannot pollinate 1 million acres of mixed crops across a continent. The technology will improve, eventually. But eventually doesn't help when the harvest is failing now. And then, at the 12-month mark, something happens that nobody was sure would happen. The bees come back. Every species, everywhere, as suddenly as they left. Hives that had been empty begin to hum again. Wild bees emerge from nowhere, nesting in the same ground burrows and hollow stems they'd occupied before. It's over. 1 year and done. But the world they return to is different. The first growing season after the bees' return produces a strange kind of abundance. Flowers that haven't been pollinated in a year are producing desperate, prolific blooms. Plants that reproduce annually have missed an entire generation of seeds, so there are gaps in fields and meadows where certain species should be, but aren't. Some perennial crops bounced back immediately once pollination resumed. Others, like almond orchards, where trees were stressed or neglected during the crisis, take years to reach full production again. The alfalfa seed supply recovers within a season or two, and with it, the livestock feed chain slowly rebuilds. Cattle herds that were culled during the shortage take 3 to 5 years to rebuild to pre-disappearance levels. Meat and dairy prices stay elevated long after the bees return because you can't rush biology. A cow takes 9 months to gestate. A calf takes 18 months to reach market weight. The supply chain has memory. The food system reconfigures. Governments that never thought about pollination policy suddenly have entire agencies dedicated to it. Bee health monitoring becomes as routine as water quality testing. Pesticide regulations tighten. Habitat corridors for wild pollinators get written into zoning laws. The world treats bees the way it should have always treated them, as critical infrastructure, because it learned the hard way what happens when that infrastructure fails. And maybe that's the real thing this year revealed. Not that bees make honey, or that they pollinate flowers, or even that they support a significant portion of the global food system. The real revelation is how invisible they were. 2 trillion organisms, working every single day, flying millions of collective miles, visiting billions of flowers, keeping systems alive that most people never think about. We built an entire global food economy on top of their labor, and barely noticed they were there. 1 out of every 3 bites of food you take today exists because a bee visited a flower. Your morning coffee, your afternoon chocolate, the strawberries in your fridge, the cotton in your shirt, the alfalfa that fed the cow that became the burger you had for dinner. All of it traces back to a creature that weighs less than a paperclip. Next time you see one buzzing around your drink at a picnic, maybe don't swat it. That tiny animal is holding up more of your world than you ever realized. And for one very long year, the whole planet found that out the hard way.